All right, I think we can go ahead and get started here. Uh, Thanks for coming, everybody. Welcome. Good afternoon and good morning to those of you who are a little bit further west. Thank you for coming to our sheet metal webinar today. My name is Jared Trotter. I'm one of the application engineers here at GoEngineer. And of course, today I'll be going through some of the sheet metal techniques that you guys can use there in SolidWorks. Just looking at uh, some of the things that you guys have entered in the chat already, I think this webinar is going to be good for a lot of you. Even if you start out with zero training, if you don't have much exposure to SolidWorks or sheet metal, or if you've been using sheet metal for quite a while, there should be something for everyone. Maybe you'll pick up some tips regardless of what your experience level is. We're going to be taking a little bit less than an hour, so maybe somewhere around the 45-minute mark today to go through some of the different topics and different things in sheet metal. So let's go ahead and get started here. We'll go to kind of our agenda for today. Going to be looking at 5 different topics here. Convert to sheet metal. We'll be looking at flat patterns, looking at assemblies, drawings, and costing, and how sheet metal applies to each one of those. SolidWorks sheet metal is included in every package, so whether you have standard, premium, or professional, you have access to the sheet metal module. There are some things that are only in some of the other packages, but we'll talk about that a little bit later on in the webinar. So looking at the very first option here, first topic, we're going to be looking at convert to sheet metal. So this is a good tool to use if you're transitioning from just a normal solid model and you're wanting to use that as a sheet metal part. So you can use your existing geometry that you've already modeled up normally to make that transition. That's one benefit of it. And then there are also additional features that essentially become unlocked once you access that sheet metal tab there in SolidWorks. So let's go ahead and go over to it. I'll go over here to SolidWorks, and I'm going to open up just this box shape here. So this is meant to kind of be a slightly irregular shape for a cardboard box. And you'll see the way it's modeled is just one singlet extrude. So it's just one basic profile here, extruded to a certain depth. And we want this to actually be a sheet metal part. So we'll just come over here to our sheet metal tab. And if you don't see this in your session of SolidWorks, once you go back to your machine and you're working with it, this is actually accessible just via the right-click menu. And you can go to your tabs and toggle on sheet metal right there. So that's how it shows up. So the convert to sheet metal option is going to be right here. It's this second option over. And once we click on that, we have our property manager over here with several different options that we'll go through and talk about. The first option here is where we can use a gauge table. So a gauge table essentially controls the thickness and the bends of your sheet metal part. There are several different tables that come with SolidWorks by default that you can choose from. You can also make your own if you have company standards that you need to adhere to. Another option, which is what I'll be showing you today, is if you enter in some of these values manually that are not controlled by that gauge table or that Excel sheet table. So the first thing that we do here is we're going to pick a fixed entity because being that this is essentially a sheet metal part, or in this case, we want this to be a cardboard box that functions the same way in terms of the bends and so forth. What we can do is just click on the bottom face here, and this will kind of be our starting point, like our point of reference. And let's see, I think there may have been something in the chat here. Yeah, so this is a solid model that we're starting with, and I'll kind of keep an eye on the question chat here, but primarily I'll be answering questions at the end, but definitely if there's something I need to address immediately, I'll try to. But getting back to our model here, we select our bottom face here, so that's kind of our starting point, and then we want to choose the edges that are going to be bent. So what we can do here is select kind of these connecting edges here. And you'll see that in the preview window, SOLIDWORKS gives us the next, essentially like panel that's going to be connected here. Now, as I go around and click these other edges, you'll notice that SOLIDWORKS puts in this little purple mark here between these two edges. What SOLIDWORKS is doing is that it recognizes that if we want these faces to be bent right here, that this cannot be connected, the way that it is right now. So SOLIDWORKS does this, makes a smart selection here for a rip edge. So what happens there is that when this unfolds, then that will these two edges will essentially separate. So we'll go through and make our additional selections here. So the front and the back there. And I've already set my thickness of what I want for the sheet thickness. Chosen a really small bend radius because of this cardboard type selection. And I want to get this top face as well. Now, if I went through and tried to select one of these edges here, it chooses this whole top panel here. And so this entire face here would then unfold. That's not what I want though. So if we just delete that edge, what we'll do instead is make use of this single line sketch. This was just created by me creating a sketch on this face and then drawing a line. We'll expand the feature tree here. Come down and activate the Rip Sketches box here, and we'll just choose that sketch from our flyout feature tree. And then that lets SOLIDWORKS know that this is kind of a separation or like a parting line. So now when I come back to bend edges and I select one edge, it just gets the point going up to that ribbed edge there. And finally, I can select the last option here. So I'll go ahead and change this option here for what our gap is, make that 0. The K factor here we'll mention a little bit. So for this K factor, typically in industry, you'll see something around a value of 0.5. That tells you where the neutral plane is, because as these edges get bent, on the outside of the material stretches, and then on the inside it actually compresses. So along that thickness, there is a point where the material does not stretch or compress, and that's what that K factor represents. That's probably the most common way to represent that bend radius. There are a few other options there from the drop down, but we'll use K factor, and we'll let that just be a value of 0 there. So we'll go ahead and click the green check, and we should see that now we've got a few things that have changed here. Of course, we see that we've got our essentially sheet metal part with bends associated with it. We see that that's reflected in the feature tree there, where it says convert to solid and then sheet metal part. And one of the other little features here in sheet metal that I'll point out with this model is that maybe you've already converted your model to sheet metal, or you designed from sheet metal to begin with, and you want to put some kind of geometry or some kind of cut on one of these bends. So what you can do is use the unfold feature. If we click unfold up here from our command manager, we'll just select the face that we want to have fixed, and then we'll select the bend that we want to unfold. And just click OK. And so now this single bend has been essentially undone. We have a feature that represents it there in our feature tree. So if we wanted to put some cuts on there, we could do that. And then after we've applied those features, like I said, there's nothing we want to really do on this part here. But after we did that, we could then refold this part. So we just click fold here, select our fixed face again, and then for bends to unfold, because this is not a bend anymore, we can just click collect all bends so that SOLIDWORKS knows what to bend back, and then we can click the green check there. That's one of the uses for unfold and fold. And then as we get later on in the webinar, I'm going to show you guys another feature, another thing that can be used for. So I'm going to come back over here. So with the convert to sheet metal option, that's one option that you can pursue if you're not starting out just from sheet metal to begin with, using that existing geometry, and then we see we have different features that you don't have outside of the sheet metal module. Our next topic is going to be looking at the flat pattern. So imagine that fold and unfold feature just applied to the whole model. And that's what your machinist or whoever's doing your burn part is going to be interested in. How's that the part need to be cut out from the stock material, and then of course the bends will be applied later. So we'll look at the flat orientation of our different parts here. We'll see how we can export that as a DXF and some of the options that we have within that property manager. Revisit that K factor just really briefly, and we'll talk about how you can include or exclude features from your flat pattern there. So if we come back to SOLIDWORKS here, we'll take a look at our next model. We're going to use this hanger part here. So of course we've got several different bends here, and we've got a few holes cut out there. And maybe before we look at the flat pattern, maybe we want to include one more feature, just a little gusset here on the bottom, kind of as a brace. So if we come here, we can select our bend face or our two flat faces that kind of join together. And this is already positioned where I want it. Here in the property manager, you can see that you're selecting what edge and then your reference point, and then just controlling the offset there of where you want this little gusset to be positioned. There's a few other options down here that we won't worry about. This looks okay right now. So just click the green check, and we'll see that we have an additional feature here. It's representing the design tree there. And here in our model, we've got this kind of protrusion, and we see where it's material has kind of been pushed in to create that feature for us. So from here, let's take a look at the flat pattern. Flatten is a feature there on the sheet metal tab or command manager. So we can just hit flatten. We'll see a few things here. One is that the part does flatten all the way out. And then we've also got our gusset profile here. Now we can choose to have this be displayed or not displayed there in our part. So let's unflatten this, and we'll see where we can control that display. So just come up here to our options. This is going to be a document property. So we come over there, and then we select sheet metal. So once we click on sheet metal there, we're going to have the options there to show the sheet metal gusset profiles when flattened, along with some other options that may apply to like our form tools or things like that. So we can toggle off show sheet metal gusset profiles when flattened if we don't want to show that gusset profile. So we can click OK there. And now when we go to flatten this, now that profile does not show up. So we can, of course, decide whether we want to do that or not. The other thing that you'll notice about when we flatten this is the orientation that it's in. So this isn't necessarily bad, but maybe we want to have this be flattened a slightly different way. So if we toggle off the flatten there, and we edit our flat pattern feature. So if we click edit feature there, we can actually choose the face that it actually flattens from. Right now it's this one over here. Maybe for a better view, we want to choose this face instead. So if we choose that face instead as our fixed entity for flatten, now when we flatten it, then it expands from there, and it doesn't extend too far down into our graphics area. So maybe that orientation makes a little bit more sense for us. The other thing that we'll look at is when we want to export this flat pattern as a DXF. for our machinist or whoever to use. So if we right click on it and we go to export to DXF, it first prompts us for a place to save this at. So maybe just save this as Hanger 1, and we'll go and choose the sheet metal option. And we have some options for what we want to choose to export. So we'll just choose the geometry here, and we'll click the green check. And you'll see what our flat pattern looks like. So we've got just that basic cutout there along with our holes. Now, if these holes or some other feature that we have here, maybe we didn't suppress it in the graphics area, maybe they show up here and we don't want to include it, we can just do a box around the entities that we don't want, and then we can click remove entities if you do not want to include these holes or some other aspect of it. So you would choose which entities that you want to delete or which ones that you want to keep. You can always undo that if you find that you deleted something by accident, and then you just hit save there, and then that DXF can be exported. So we'll go ahead and exit the flatten there, and I've got a question here on form tools. So I'll show another example of that a little bit later on. Form tools essentially act as like a punch or a press into the sheet metal to create some additional geometry. But again, I'll show another example of that in a few minutes here. So come back over here to our flat patterns. We'll see that you can control the orientation. You can export that as a DXF, and then depending on your machining operations, maybe that's a conversation to have with whoever does the bending operations. You control that K factor to control exactly how that's bent and make your measurements come out correctly. And then of course you can exclude or include certain features there. Our next topic here is going to be assemblies, where you can use your sheet metal parts. So you can use kind of a combination using your sheet metal parts along with your standard parts, or all sheet metal parts, just depends on what you need. You can also use interference detection because you are working in an assembly environment, just making sure that things don't collide with each other. And then you can also use in-context referencing when you want to make certain changes to your model. So let's take a look at an example of that. Go ahead and close out this guy and open up one of our assemblies here. So here we have an assembly, and what we're going to need is to create an additional part that kind of acts as an enclosure or a guard around this area. So one approach to doing that, I'll just switch the display states here, is to, within the context of the assembly, go ahead and model some geometry around it. So we've got a solid model that kind of encapsulates it here, and we want to change that to a sheet metal part. So go ahead and open this part, and as it stands, I've already done the convert to sheet metal option. We've looked at that in our first example, and here I just have an additional configuration where I've gone ahead and applied the sheet metal features. So now it's got the bends in there, but that's not all that we want to do to it. So maybe we want to apply some additional geometry here. And to do that, we're actually going to look at one of the forming tools. So if I go over here to the design library, there are a number of forming tools that that come stock with SOLIDWORKS, and then you can create your own as well. So what we're going to do is bring in a louver, and we just drag that over onto the plane here. And we'll need to rotate that. This is going to be kind of like a punch into our model. And we'll just flip the tool here. I believe that's going to be needed to rotate again. Get the right angle. There we go. So we can control the rotation angle there until we get it the way that we want it. And that one looks pretty good. We've got two different configurations that we're going to use, or that to choose from. One is the long, so we'll leave it there. And when we come over to the position tab, we can actually place a few more if need be. So we'll go ahead and place 3 of those. And then we can use just our normal sketch tools in order to create some additional relations here. So maybe we go ahead and maybe lock these guys down, then associate that to the midpoint. So we can just use our typical sketch entities here and go ahead and locate these guys. So maybe we apply a few of these, apply the midpoint there. Just apply a few relations to get this completely defined here. And now with that done, we've made a little bit of a modification here to our geometry. And you can see that it has an opening there, kind of that little form punch there. So that's been completed. We'll go ahead and tab back over to our assembly, and we'll just switch the configurations there to our sheet metal model. And you'll notice that in the assembly environment that you don't have the sketch, or rather the sheet metal tab, because that applies just the parts, but you can still do some in-context relationships using that tool. So if we just click on our model here, or rather this cover part, we can edit that part, and now we do have the sheet metal tab that we can use. So maybe we just want to put another edge flange up here. So we can choose this basic feature for an edge flange. We want this edge to be the one that comes out. We can choose for that to be set a certain distance, or we can relate it to some of our other geometry here. So for flange length, we can just select up to vertex and select this end here, and then that'll be as far as that flange extends. And maybe we want to go ahead and break these corners here. So we can choose corners, break corner. We want that to be applied to this face. We can choose whether this is a chamfer or a fillet. Maybe we just set that to 5 millimeters. And some of the other features that you might apply normally to a part, like your hole wizard or extruded cut, you can do that as well. So we'll just make sure that we've got the right hole here. Go ahead and apply a couple of those holes. Make sure that the end condition is correct here. Up next, and go ahead and click OK. And maybe we want to take advantage of the symmetry that we've got in the model. So we just expand our part here in the feature tree. We've applied a few features. We've got our hole, break corner, and the edge flange. And maybe we just want to mirror that about our front plane there. So we do a control select of all of those, select the mirror function, and let's see, it should be able to work here. There we are. And just apply that on the opposite side there. And we can go ahead and exit that feature. And now maybe we just want to make sure that there's no interferences here. So we can take advantage of the assembly level feature that can also be used on multi-body parts, but we'll look at here in the context of the assembly. Here on the Evaluate tab, we can check interference detection, and we'll just come down here and make sure that Treat Subassemblies as Components is selected there, and then that way we're only looking at the potential interference between the top level components, so our model that we have here, and then the rest of the model basically. So we can click calculate, and then sure enough, we don't have any interferences, so we're good so far on that. So those are some of the things that we can use sheet metal for on the assembly level. Even though you wouldn't apply sheet metal features to an assembly, you can do it on the parts in the context of that assembly and use some in-context referencing there. And then, of course, using the interference detection to make sure that you don't have any parts colliding with each other. Next thing that we'll look at is sheet metal parts as it applies to drawings. So when you do a drawing, there are certain tables that you can use to call out. If you have a lot of information that needs to be conveyed and maybe it clears up the actual display a little bit. We also have annotations that we'll take a look at. And then finally, processes that we can use to kind of show the different stages of a bend. So let's take a look at those. Come back over here to SOLIDWORks. Just save these guys and bring up our next model here. So kind of returning to our hanger part, you'll see that on our first sheet here, we have some of our typical drawing views, and we call the dimensions out like we wanted to. If we go to the flat pattern here, we'll see that we've got this view. So we can have that displayed, however we want it to. If we decide that we wanted to rotate that, then perhaps we could do that. You'll notice here that we have different bends. So I'm just going to move this up a little bit here. You'll notice that there are different bend values here. If you click on the actual model here, or the view, you'll see that there's a toggle for bend nodes. So we can choose to turn that on or turn it off, just depending on our preference. For the moment, we'll leave that turned on so that I can show you another option, which is if you want to actually see these bend lines created a certain way, or if you want them displayed a certain way, you can go to your options and we can control the color. So if we go to document properties here and we go to sheet metal, you'll see that for bend lines up direction, the down direction, we can control the color here. So maybe we choose blue for the up, and then maybe a red for down. And just click OK there. And now we see the lines that are indicated right there. They're color coded. Let's go ahead and turn off the bend notes here, because in addition to displaying them right there on the model, we can call out a table. So if we go to tables here on our annotation tab, we can select bend table. And there are several different templates you can choose from. We'll just do the default here. And then we have our table here to tell us, at what point these need to be turned down or up, and by what degrees or by what angle. One other option that we'll choose to show here is that if you want to show the process for this bend, if you want to show which bends need to be done first. So do another sheet here and have that ready to go, but we'll go ahead and open up the model here. And what we'll do in order to create some different views here, we'll go ahead and let's press the flat pattern here for the time being, that is. Maybe what we want to do and show is the different stages of that process, and we'll use configurations in order to do that. So right now we have our default configuration, and we can go ahead and flatten it. But from here, we'll go ahead and create another one for another configuration rather, for our processes. So we can add a configuration, and this will be our first bend. And then we'll come over here to our feature design tree. And if we expand flat pattern, we'll see the different processes here. So maybe we just start, and maybe for our first bend, we want to have all of these bends to go down. So we'll choose these 3 features here in our feature tree, and we'll suppress them. So these 3 flattened features, those will be suppressed. Then we can come here and proceed and add another configuration. So maybe this is our second bend here. Come back to our tabs, and we'll flatten this guy. And then we'll do a third bend. Come back over. And then this is our final one, which is actually the same as our full configuration there. So with that done, maybe we go back to our drawing here. We can go to sheet 2. And maybe just bring in an isometric view here. And we'll create a note to indicate the configuration. And just link that to the property. So it's the model that we have here. We'll select SOLIDWORKS configuration name. Go ahead and click OK. And once we have that, then we can just make some copies of this configuration here, or of this view, and we'll change them depending on what configuration that we want to show. So the first one here, maybe we want to show the first bend, and then we come over here to the second one. That's our second bend, and then this one is our third bend, and then this is just the flat pattern. So maybe we wanted to rearrange that or show that a little bit differently, but the idea is that we show the different stages in that process there. So go back over here to our PowerPoint here. So some of the different tools that you can use, the different tables that you can bring in. You can have a table for your hole punches, or for your bends, so your bend table punches, and show which annotations that you want, whether you're just calling out configuration or you're indicating something else about the drawing. And then you have your processes that you can draw attention to by means of configurations, and just to show the different stages there. Our last little topic here is going to be with costing. So with costing, the advantage here is that you can actually track your manufacturing cost to give an estimate of how much each of your parts is going to cost. And we can use this on parts and assemblies depending on the package. So SOLIDWORKS Standard actually does not have access to costing. SOLIDWORKS Professional, you can do costing with parts, and then with Premium, you can do it with parts and assemblies. So we'll take a look at the examples there, how you might use that. Look at our last couple of models here. Let's go ahead and close out of this one. So we'll start off by looking at this assembly and just maybe focusing on this one part here. that assembly being mostly made of sheet metal. So to access the costing feature, that's going to be on your Evaluate tab, and it's going to be really towards the end. So you'll probably have to click that arrow there at the very end, and you're going to see costing. So when you open that up, you'll have access to some of the default templates that SOLIDWORKS gives you for costing. You can actually use this with things beyond sheet metal. You can use this for machining operations. So if it's like a mill and a lathe, you can use this for 3D printing, some things of that nature. And then of course, sheet metal, which can kind of be optimized for that. You'll see that there's a costing template here that we have to choose from. And within that template, there are different classes of materials that we have to choose from. So that if we go through here and we choose different materials, so if I change this to a copper alloy, so you can see down here how the price changes. It goes up from what it was previously with the aluminum alloy. And then some of the things that come from that template can be updated right here if you want to change the material cost or something like that. And then depending on which class and which material that you have set and which template that you have, you can choose to price this based on the material weight or on the sheet size. So those are the two different ways that you can address how much that would cost. And you can also choose the total number of parts that you want to produce and use that in your costing. If you want to change this, there's a template editor here, and I'll mention a little bit more about that once we finish up looking at this part. But once you have kind of the settings that you want, you can actually do a cost or generate a report. And we'll look at that in on the assembly level as well. So you can choose, what quantities that you want, and you can have, your own template that you choose. One other thing that I did not mention is that you can customize this so that you add other operations here. Maybe it's your setup, maybe it's the welding, or things of that nature. Now, because we're operating in premium here, we can go ahead and Control Tab back to the assembly. And we'll take a look at costing there as well. So you can have separate templates for your sheet metal assemblies as opposed to the part. Kind of the same idea there, where you have setup costs that are specific to assembly operations, and then a few things that you can modify within the costing area here. And you can also generate a report on that. I've already got a report generated for this one, so I'll just bring that up right quick. So this is what a typical costing report might look like, where you've got the date and time that you had generated, how many that you want to produce, and then one thing of interest down towards the bottom here, of course you've got your total, and then you've got your setups there. So you can, of course, customize this however you want. In this case, we're showing each part, how much it will cost there. We've got some different configurations that we had access to, so we're specifying those configurations there for each component. Again, this can be customized however you need it to be done. Now, in addition to these things that I've mentioned, maybe you want to get some more information on setting up your costing templates and customize it. So there's actually a really good webinar that was put together by one of our other application engineers, Darren Grosser. That video is on YouTube, SOLIDWORKS tutorial costing template setup. I recommend checking that out if costing is something that you think that you could use or use better. So he really takes a deep dive into how to set that up. So those are the topics that I want to cover today regarding sheet metal. If you're interested in following us and getting more information on the goings on of GoEngineer and our trainings and so forth, you can sign up for our newsletter at goengineer.com/signup. If you're interested in having more training, whether it be on sheet metal, our actual sheet metal course, which covers more than what I did today, or if you want to take some of our other classes like SOLIDWORKS Essentials or Simulation, other those classes, you can go to our website and find the training. So it's goengineer.com/training and register for that. And then this webinar, and then our other little tutorials and tips and tricks will be on our YouTube channel. So that's where you can revisit this information or find out any other information that you might want regarding training or the services that we provide. Thanks again for coming. Hope you guys have a great rest of the day and have a good weekend.